Hello everyone. Today we will solve two sums problem. This problem is the first in the blinds list. Also, this is the first in the LeetCode's problem statement. The problem says that given an array of integer nums and an integer target, return the indices of the two numbers such that they add up to the target. Right? You may assume that each input would have exactly one solution. This is a very important piece of information that in a given array there is only one solution, right? And you may or may not use the same element twice. All right. Let's take an example of this particular input where the array is made of 2, 7, 11, and 15 and target is 9. If we annotate this array with their respective indices, we will have something like 0, 1, 2, and 3, right? Then if the target is 9, then we can see that these two elements 2 and 7, summation of this is equal to 9, right? Hence the solution would be 0 and 1. Similarly, if we look at this particular input array and annotate it with its respective indexes, then the target is 6 and output is 1 and 2. If you see these two elements 2 and 4 sums to the 6. Same goes with this. The target is 6 and these two elements which are 0 and 1 is the solution of it. With this understanding, our algorithm would be we need to find all the possible pairs in the array. Out of all these possible pairs, we want to find the pair whose sum is equal to the target, right? So accordingly, our code would be two pieces of information is very important for us. For the first iteration, the I is starting from the start of the array and j is starting from the one element to the right of the array. Let's say that we take 3, 2 and 4, right? And their indexes is 0, 1 and 2, 4 and their indexes is 0, 1 and 2. In this example, the possible pairs would be 3, 2, 3 and 4 and 2 and 4, only 3. So what we are doing here is we are pairing the first element with the elements it's next to it 3, 2 and 3 and 4 and 2 and 4, right? So that's how we have written our algorithm as well, where we are starting from the first. However, the all the pairs that we start from the one element right to that I, which is I plus 1, right? This is very important for us. So with this, let's do any simulation of our code. If we take an example of 3, 2 and 4 and their corresponding indexes would be, if I is equal to 3, which is at the index 0, then j can be either 2 or 4, which is at the index 1 or at the index 2, right? If the same summations of with 3 and 2 is equal to 5, which is not equal, then accordingly same 3 plus 4 is equal to 7, which is again not equal, right? Then we will have to iterate the I to plus 1. With that plus 1, the I would become as something as 4, 2 and j can only become as 4. If we see the sum of these two elements 2 and 4 which is equal to 6, and that's where if the sum of these elements is equal to 6, here we are returning it back. So this is our answer. In case we do not find anything, then we are returning the empty integers array. Now, if we look at the time complexity of this solution, here, this is the first 4. So it will have a complexity of O of n. This is the second 4. Then this will have a time complexity of O of n. In that case, the total time complexity will be O of n into O of n, which is O of n square. And its space complexity is O of n, since we have not used any space in this complete example, right? Now, With the complexity O of n square, can we do better than this? We will try to find a solution with a time complexity of O of n. If you see, the sum of first element and second element is the target. That means the second element is equal to target minus first. So at any point of time, we will always know the target as well as the first element. First element, when we are iterating an array from the left to the right, then whichever element that we find is the first element. If that is the case, if we know the target, if we know the first element, in that case, all we have to do into the remaining array is to find the second element, which is this one, right? Let's take an example of this earlier array. Here we will iterate from 3 to 4, right? If we know that the target for us is 6, and if the first element is 3, then all we need to find in this other array, in the remaining array, is the second element. In this case, the second element will be 3. If we find 3 in this remaining array, then we can say that, hey, I knew there was a first element which was 3, which was complement for that target sum. It was present earlier, so I can just use it. And whenever I get the 3 in the remaining array, I can just return back from there, right? So you see, I have to do the iteration only once, right? Same goes, if we do same goes for the other element, which is 2, right? Then if the target is 6, first element is 2, then all I need to find is the second element, which is 4. I have 2. All I need to find in the remaining array is the element 4. Here I do have the element 4. Then I can say that, hey, there was 2 before. In that case, our solution would be 1 and 2. Right? So this is how our solution is. Now, the question comes that if we are starting from the left and to the right, whenever I go to this place, let's say at the farthest right, which is 4, then how would I know what was the element before this, right? We need to store that. So in for this particular use case, we are going to use an hash map. So in the hash map, the key would be the element itself and the value would be its index, right? For If we consider this particular example, 3, 1 and 2, our hash map would look something like this. The element is 3, the index for that is 0. The element is 2, the index for that is 1. The element is 4 and the index for that would be 2. With this, let's write our algorithm. First, we need to save all the elements into the array with their respect to index. This is one of the example for it. Second, we will have to iterate through the array once again, and we will try to find the complement. The complement is nothing but this part where the second is a target minus first, which is the complement. If the complement is found, then we will return it back. There is one more condition for the complement. The complement should not have the index as equal to the index that we are iterating right now. For example, if in this particular array 3 to 4, if we are at 3 which has the index 0, and if we try to find the complement of it, which is again will come as 3, considering the target is 6, which will again come at 0, then this index and this index should not be equal, right? So our code with this will look something like this. Like in this first for loop, if you see, we are creating the hash map. Here we have declared the hash map. Here we are putting the things into hash map. Once the things go into hash map, this is where we are trying to search it. First thing that we have calculated is the complement. Complement is nothing but the second element which we talked before, which is again target minus the particular element, right? Then we will try to see into the map if the map contains the complement, and if the complement is there, the complement should have a different index than the current index, which is j. If both of these conditions are satisfied, we are returning solution with the pair j is the current element and the index of the complement, right? Let's try to draw a dry run of this. In this example, if we consider this array, then these are the indexes of it. With these indexes, in this particular for loop, what we will get is, let's consider the I is equal to 0. In that case, the hash map will look something like empty. From 0, what we will do is we will put the nums of I, which is nums of at the element at the index 0, that would be 2, and its index is 0, right? When I is equal to 1, then we will iterate to this particular element, then the value would be 7 and its index is 1. Similarly, the hash map, now our hash map will look something like this, right? Now we will go for the second iteration, which is this iteration. If we consider j is equal to 0, then the element will be 2, and if the target is 9, then the complement would be 9 minus 2, which is equal to 7, right? Now, if we try to see 7 into the hash map, if it is present here in this particular line, what we will do is we will try to see if the map contains the element, if map contains the complement. Here, the complement is 7, and in the map, we have the complement. Awesome, right? Then map.gate of complement, which is 7, the gate would come out as 1. Now this 1 is not equal to j, which is 1 is not equal to 0. That means this will pass. So this solution will return the index of j and map.gate of complement. In that case, the solution would be the index of j is nothing but 0 and the index of complement is 1. So this is our solution. Here the time complexity will be O of n, where we will iterate through the whole of the list, right? Similarly, here in the worst case, we will iterate the complete list. So the time complexity of it, since these are not cascaded, the time complexity of it will be O of n plus O of n. That is O of n. Also, now if we consider space complexity, we are using this hash map. This hash map will hold all the elements that are present in array. So the hash map will have a time complexity of O of number of elements in array, that will be O of n. Now in this equation there are still a scope of improvement. Here if you see, we are creating two passes. This is the first pass, this is second pass. In the first pass, we will iterate through the whole array and we will store everything into the map. So we are waiting for that map to fill, then we are going for the second iteration. Now, since at any point of time, the map will be filled with all the elements before this, right? If all the elements before this is in there, then I can always find the complement. I can always find if the complement is present in the map or not, right? So accordingly, we can change this code so that we can pass it into single. So now this will be our improved solution. Here we are again using the hash map to store the element and its corresponding index. Then here we are doing our most of the operation in only one pass, right? Now if you see, first thing that we are doing is we are finding the complement of this particular element. We will try to see if that complement is present into the map. If it is present, then we will return back the complement's index as well as the I. Otherwise, we are going to put the element into the map with its index, right? If we do not find anything after the complete the iteration, we will just return back the empty integer array. Now let's do a dry run for this particular example that we have seen before, which is 3, 2, and 4, right? 3 has the index 0, 2 has the index 1, and 4 has the index 2, right? For I is equal to 0, the complement would be, the target for this is 6 actually. If the complement would be the 6 minus 3, that would be 3, right? Now in the map, there is nothing at this point of time. In that case, we will put into the map. So the map would have something like 3, 0 as the first element. Now let's consider I is equal to 1. Then the element at 1 would be 2, right? In the 2, the complement of 2 would be 4. Now, if we see into the map has only element 3 is equal to 0. It doesn't have a 4. That's why we will put into the map. So now the map would look something like here 2 and it's 1, right? Again, we will iterate. Again, we will iterate the I. In this case, our I would be equal to 2. The nums at I is equal to 4. Therefore, the complement would be 2. And if you see this particular complement is present into the map or not, yes, it is present into the map. That's why our solution would be the index of the complement and the I. In that case, the index of the complement is 2 is equal to 1. I did not put this here, but the index would be 1 and the complement's index is equal to 2. So answer would be 1 as 2.
Now we will try to code our algorithms. We talked about 3 different ways to solve this. First we will go with the brute force approach, then we will go to the 2-pass algorithm. After that we will go to the single pass algorithm. Here is the simulation for the brute force approach. If you see, we have created 2 for loops. This is the first for loop, this is the second for loop. So these 2 for loops will create all possible pairs for that particular array, and out of those pairs we are checking if any pair has the sum equal to target. If that is the case, we will return back the indexes of that pair. I would be the starting index, j would be the second index. In case if you don't find anything, what we will do is we will return back the empty array. Let's see if this works. Before that, here are some of the test cases that we have. Yeah, this works. Let me try to submit this as well. Awesome. If you see, we took around 47 milliseconds here, and that beats around 14.44%. Okay, this is our second solution. Here we are using a HashMap. HashMap will be used to save the indexes, the elements and their corresponding index. This is where we are populating the HashMap. Now we are iterating through the array once again. Here we are calculating the complement here. If the map contains the complement and the complement's index is not equal to the current index, which is this iterator's index, if that is not the same, then we are returning it back. Here we are returning it back the first, returning back from the map, since the map, the elements in map will be always to the left. In case I is equal to 2, then elements into the map will be from 0 and 1. That's why we will be returning this back and then the I. In case we don't find anything, then we will just return back the empty array, right? Let's see if this works. Awesome. Let's try to submit this as well. Awesome. Now if you see, we are getting around 4 milliseconds. Earlier, if we had with the brute force approach, we had around 47 milliseconds. Now this is how our code will look like for the single pass. Here we have the same hash map. However, we are doing this in a single pass. If you see, what we are doing here is we are trying to find the complement. If the complement is present into the map, then we are returning it back. Again, the complement will have the first element into the return integer array. If the complement is not present, then we are going to put it there. Alright, in case we do not find anything here, we are returning back the empty array. Let's see if this works. Yeah, this works. And let's try to submit this as well. Oh, After submission, looks like we are getting the runtime as 2 milliseconds. Comparing this with the existing one, we have got the superior performance now. Right. Yeah, that's it for this question. Thanks for watching.